Okay, so I think recording is already started. So see, so these are the two properties of a basis. Okay, it is a minimal spanning set and maximal set of independent vectors. So what is the meaning of this minimal? The first point, minimal spanning set. What is the meaning of this?
Means smallest, having least number of elements.
Yeah. So set of those vectors. So this will be the smallest number of vectors. If we take the linear combination, all the linear combination of these vectors, we will able to span a space, a vector space. Okay, some vector space. Maybe I'm taking a plane. Okay, the two-dimensional vector space. So, so this is if it is if it is a plane like 2D, then it can be spanned using two vectors, right? And one zero vector, of course. So basically three vectors. So v1 and v2. These will be two independent vectors, and if we take the span, and we will able to span this. So this is a minimum in number. So this is called minimal spanning set. Okay. And then uh, or other condition, if this is true, this is enough, and if it is maximal independent set, so basically it will follow both the properties simultaneously. Okay, I mean it cannot happen that it is a minimal spanning set but not a maximal independent vector. It cannot happen. Okay? If one is true, the other will automatically true. Okay. So other condition is maximal independent set. Suppose we are spanning R3. This is a vector space. Then maximal independent set means, so what is the maximum number of vector that may be independent in this vector space?
Three.
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 Yeah. So three vectors.
So, can we say that the basis of vector
Hmm.
have exactly n number of independent vector that n comes from the at the rank of the vector space. So whatever it is called, that R3, like
Dimension. Yeah. Dimension of that vector space is equal to the maximal set of independent
the
vectors. Okay.
cardinality of this basis, right?
Yeah, cardinality of the basis set.
Hmm.
Okay. And so from here, okay, wait a minute. So from here, what is the next topic? Next topic is finding a basis vector. Okay, and then rank dimension. Okay, so because we know this is a maximal independent set of vectors, is it it can be different or it must be the same? I mean, question is same or different?
Please repeat.
Yeah, I mean this set of, suppose we got a basis. Okay, a
Hmm.
set some set. Okay, then this basis, the set of these vectors which are forming bases, that means which are spanning this vector space. Okay, for that
Hmm.
it is basis for it is unique or
No,
same.
it's no, no, it is not unique.
Yeah, so any set of independent any set of independent vectors can form basis, right?
Yeah, yes.
Okay.
Cardinality should be unique.
Yeah.
Cardinality is unique and standard basic basis is unique.
Okay, then can we say that the cardinality of this basis set is a dimension of the vector space?
Uh, in
Yes.
normal cases, like Rn we can, but I don't know about the matrices and the related spaces.
Okay. Yeah. So so it is looks like it is dimension. Okay. And then there is one more thing. Then why? So in the further in the course, you will be so you will be having basis. So basis can be different, right? But there is a notion of standard basis. So suppose we want to space uh, we want to actually span R3 or R4. So can you tell me what is the standard basis for this R4?
1000.
1001.
Zero one zero zero
001.
zero zero one and zero 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 one.
Okay, so we call it E1, E2, E3, and E4. Okay, so this is a standard basis, and there is one more property of this basis, the standard basis. These are independent vectors, so this is the basic property of the basis itself, but it has every vector has the magnitude one. I mean the norm of one. Okay, what is norm you will see it later. Okay, norm is basically the length of a vector. Okay, you can just correlate with the length of a vector. Okay, so all the vectors have norm 1 and they are independent. So basically we call this as orthonormal set, orthonormal basis. Okay, orthonormal basis. And how we get it, and how can we reduce any basis to a orthonormal basis. Okay, or orthogonal basis only. Okay, orthogonal basis. So independent is a different thing, but suppose v1 and v2 are independent, but it is not necessary they are perpendicular. Am I clear? These three vectors, suppose v1, v2, v3, they are independent because they form basis. Okay, so it is clear they are independent, but is it necessary they must be perpendicular?
No.
Perpendicular means if you go in n dimension they becomes this orthogonal. So it is not
Ortho.
necessary it is orthogonal. Okay, but suppose if we somehow convert them into orthogonal set. Okay, then if we take any dot product of any two vector we'll get zero, right?
Yeah, zero.
Yeah. And furthermore if we divide the every vector of the basis by its magnitude or by its norm, then we get orthonormal basis. Okay, so first we get orthogonal basis, and then dividing by the norm we get or the magnitude. For this level you just remember the magnitude and make it a unit vector. The every vector in the basis vector make a unit vector, then we got a orthonormal basis. Okay, this is the concept so that you can relate when you go ahead in the course. Okay, so this is for basis, and then it comes second, how to find the basis for a vector space. So so any we can take any vector from the set. Okay, and then we take another vector which is independent from the from the first vector, and then we take another vector which is independent of the both vector. Okay, so this is and so on. So this is how we actually form the basis. Okay. And then our rank and dimension. So suppose we have v1, v2, and v3. These are the three vectors we have, and span of this forming a vector space v, and we want to know what is the dimension of v. So how do we know? Okay, this set is not may not be independent. Okay, may not be independent. Okay, so we cannot say that there are three vectors in the spanning set, then the spanning space, the spanned space is also of three dimension. We cannot say certainly. Okay, is it clear? I mean, this set, the spanning set, may have dependent vectors. Is it clear?
Mm,
Yes.
yeah. So we can say that this vector space
Hmm.
is at least in three dimension.
Yes, that we can say at least. Sorry, what you say? At least, at most.
No, at least because stem have yeah, sorry, at most, yes,
Yeah,
yes,
at
at
most
most.
three
Hmm.
dimension. Yes.
Yeah.
So yeah, that we can say actually, but it is possible there are some vectors which are dependent. So we are not sure. So for finding the dimension, what we do, we again, so one way is we'll make a determinant. Okay, we'll make a determinant and then see. Then sorry, we will make a matrix. Okay, not a determinant. We'll make a matrix using these vectors. Suppose v1, v2, v3. We make a matrix and then reduce it to RREF. Okay, to reduce echelon form, or REF is enough, and then we look for pivots. Okay, so the number of pivot equals to rank,
Rank of the matrix.
rank of matrix. Remember, rank word is defined for matrix, not for
Determine.
vector space. Okay, there is no such rank of a vector space. Okay, rank for of a matrix is actually something. Okay, and number of independent variable.
But the lectures professor said that we can use both of the terms for vector spaces, rank
What?
and
Uh, I mean, yeah, I don't know what is the rank of a vector space. Okay,
No,
so
no. Sir said that in upcoming like weeks, the rank will be defined for something else.
okay, okay, okay. So
With high content.
yeah, yeah. So that is also one thing. Uh, okay, so then just don't focus too much on this because it is not that much important. Okay, you just take this rank. Okay, rank when we get this matrix would have a rank which is equal to the number of pivot elements. Okay, and
Pivot,
how to
pivot, sir. Sorry, sir. Sorry to interrupt, sir. The
hmm,
pivot element may or may not be one.
may not be one.
Yes.
No, no, pivots are one always, right? Pivot will always be one, right? Leading entry should be non-zero, right? Non-zero means one, because we can always divide by that row by that number, by that leading entry. So one means it should be non-zero. The pivot should be non-zero. Okay.
Means it can be any integer is it necessary
Except
to
zero.
the
Except zero.
it can be anything except 0.
Any integer except zero. Any
Okay.
integer or for rational number. Okay.
That is the biggest confusion for REF for me.
See. So suppose if you have
Now
three
it's clear,
vectors.
sir.
Yeah, yeah, but still I'm just suppose you have these three vectors. You want to know whether they are independent. You want to find the pivots of this matrix. So you convert this. Okay. So somewhat here you will get one. Okay, and then it should be zero. Okay, these are the properties, and then uh, maybe one row would be entirely zero, and here it a second pivot. Okay, and so that if this is a pivot, then this entry must be zero, and below it zero, and it could be non-zero, could be non-zero. Okay,
Okay, sir.
so these are the first column and third column, first column and third column has pivot, So corresponding first and third variable
Dependent.
dependent, and second variable independent,
Free or independent.
free variable, yeah, independent. And so this is the cardinality of these the independent variables. Okay, that we call nullity. Okay, what is nullity? Just forget, or you'll see later. Okay, but because we have this rank, so corresponding word is nullity. Rank is pivots, right?
Yes.
And what is remaining is nullity.
Okay, sir.
Okay, and
So
together,
rank of the this example which you have shown is two.
yeah, here rank is 2. Here rank is
Yes.
2. Okay, so one said it must be 1. If it is not 1, then we can divide this row by that number and make it 1. Okay,
Yes.
but if it is 0, then we can do it. We can do nothing. So so leading entry must be 0. So pivot must be non-zero. Okay.
Yes.
Okay. So then so whatever is the rank, and what remaining is nullity, and together makes number of variables or number of column. Okay. So sir will prove this. Okay. Later come in the next week. Why I'm telling you, so that you get this motivation, because we are not studying any random terms like rank and dimension and not basis. These are not random basis. We will go somewhere, okay, towards orthonormal basis, orthogonal basis, and here they make lot of sense. These actually terms orthonormal basis make lot of sense. Okay. uh, Even basis is actually enough, because basis can represent a vector space, right? I mean, the linear combination of the vector of a basis can span the whole vector space. So basis is also
Yes.
important. This is thing. Now you want to ask anything, or we should solve the activities.
Activity question. Okay. I think.
Okay, activity we can solve. Okay, rank damage. So one thing actually remaining, the Gaussian elimination. I think I have covered. Let's see. Gaussian elimination. Uh, we can actually Gaussian elimination means this is the process. This is called Gaussian elimination. Uh, Finding the independent variable and dependent variable. Okay. So using Gaussian elimination, we can find the dimension. Okay. So what is the dimension of a vector space? If if we have two pivot and one independent variable of a 3 by 3 matrix, and can we say what is the dimension of such vector space? It will be 2 or 1.
Two.
2, right?
Mm.
Okay, because one is independent variable, and so this will be independent
Oh,
from both of these, and because these two are dependent, so we can take one, right, from there.
sir, can you please write an example basis for this vector space which you described by pivots? Any
Actually, this is I'm not sure what is the RREF of this. So can you tell me what is the RREF? Then I can tell you surely.
RREF like this one 10 this 100001 and 000 this one you write there.
Okay, I have written this not exact. Okay, I mean, I have
Yeah,
taken the
yeah.
exact.
Okay. Let's suppose that
Hmm.
this is RREF. Then you can you give me example of what kind of basis will it have?
uh, See, so what we will take, we'll have one vector which is independent. Okay, then we can replace that vector by some t. Okay, and then so basically basis would be these two vectors. But again I'm saying this will be actually absurd. We have to find the RREF first, then only I can tell you what is the basis, because basis would be two vectors, okay, which are independent. So because here we say first and third column are dependent, so then we can take either 1 and 2, or 3 and 2, and 3 and only 1 and 2, or 2 and 3. So any two columns would make a basis, okay. We cannot take 1 and 3. Is it
So
clear?
shouldn't we say that first and third variables are dependent?
uh, yeah, that is the true, that is true. First and third variable is dependent, but actually we have to check. It could happen that the first and third column are also dependent, okay. It could happen. Again I'm saying take a caution, because we can take a v1 and v2 v3 as a row vector. In that case rows will be dependent, okay. But which one? No, but definitely two of the rows will be dependent if we have a two dependent variable, okay, out of three. You understood? If we get a, if we get at least one independent variable, that means two of the
Yes,
rows.
so I'm getting in
Yeah.
terms of variables, I'm getting it. But when you said that the column is independent, that's
Yeah,
when I
see,
have the
see,
issue.
see, see, see. If one variable is independent, then what is the determinant of this matrix?
Uh, one
Zero.
variable, yeah.
Zero. Determinant would be zero. If
Mhm.
determinant is zero, that means one row is zero,
Yes.
or maybe one column is zero, right? So,
Hmm.
so it is actually certain that two of the rows are dependent, or two of the columns are dependent. It's certain, okay. Using some linear some row column operation or a row operation, if we apply, we'll get two of the rows same, okay. Those rows will be dependent, right? But we
And if
cannot
we
say,
write it, so
but
if
we
we,
cannot say surely that which of the two rows are independent, which of the two rows are same. For that we have to use this Gaussian elimination, okay. Then only we can tell. So so as there are two pivots, then the corresponding columns, if we had taken this as column, and all the corresponding rows would be dependent.
Sir, till now I don't know about others, but I only have seen
Hmm.
somewhat like square matrices like vector spaces where like basis where we have equal number of vector and equal number of coordinates or variables in that vector.
Hmm.
So what if we have a rectangular shape like thing like we have more vectors than yeah, or
Yeah,
more
yeah, yeah.
variables in each vector than the number
Yeah,
of vectors itself.
yeah, understood. So understood. Also for that, yeah, for that it will be actually different. So that's why I just talking about this particular concept. Okay, the square matrix. If it is a rectangular matrix, suppose rows are less and columns are more, that means variables are more, right?
Yes,
There
sir.
are more variables. So that means there will be, it is certain that there are some variable which is independent, okay. So in that case, if there are independent variable, that means uh, so also we can just focus on those which are pivots, okay. So that number actually be the dependent variable in that case, which have we have pivots. So for that case, we can take explicit example, that would be better if you, okay. From the activity questions, you will certainly encounter some question there. You will get a better idea. So the main point that that you should remember here, okay, for Gaussian elimination is, we take this matrix. This matrix could be rectangular, okay. I mean the determinant may not be defined, for this. In that case, we just reduce, not in that case, in every case, we just reduce it to the RREF and C for the pivots. The number of pivots would be the rank of the matrix. Okay, that's it. And dimension is so number of independent variable plus plus the so we will club together the dependent variables. Suppose there are two, okay, so we'll take just one from there, and if there are three, then we will take so basically the number of independent vectors will form the dimension of a vector space. Number of independent vectors. I should write this. This is important. Number of independent vectors from a spanning set of vector space form the dimension of vector space. Okay. So now we can solve the questions. So before going to the activities, I just want to say if you have already solved these activities, then we can do something different like Mobius. Do you guys have this access to this Mobius platform? All of you?
Oh, which platform?
Mobius.
No, sir. No, sir.
No, sir.
It is only available for those who have taken the mentorship.
Oh, okay, okay. No problem. So yeah, activities are fine. Yeah. So then just solve one by one. Okay.
Activities, I think if uh, all people have done this, then you can start with solve with us. Um,
Yeah. That would be actually good. Okay. Okay. So this is the first question. So for this, what the concept will be used? Uh, Algorithm to obtain a spanning set for a non-zero vector space V. First start with the empty set and then add non-zero vectors. They said then uh, then we take if a span of S is V, then we are done. Okay, if it is not, then we take one more vector which is independent. Okay, otherwise we choose V2 from the V. Okay, minus the spanning set of S1. I mean that we already have the vectors in S1. We'll remove all those combination of those vectors. Okay, and then basically, so it is other ways to say that we take the another independent vector from the set we already have. Okay, span of S1, and then add that vector and make a set S2. Then again check whether span of S2 is V. If it is, then we are done. If it is not, then take one more vector which is independent from all the vectors of S2, the spanning set of S2. Then we'll add this. Okay, so this is how we will do. So all of you solve this first question. If S is this, then okay, solve this question. After some time, I will discuss this.
All four.
Okay, so anyone want more time? Okay, yeah. So then suggest me some ways to approach this question. Anyway, I mean, how are you guys are solving this question?
Just taking like taking each of the options, whether they are the linear combination of the given vectors or not.
Okay, so the first option is you can just directly see it is written as the linear combination of these two.
Yes.
Yeah, so this is already, it is saying which of the following elements are the span of S. So this is true. This is the
Mm.
span. Okay, 0.
Yeah.
Okay,
Yes.
what is the how do you check this?
I can take any of the vector actually value minus 2, 3. So it is 2, 1 and minus 1. Yeah. So if I add the second and third and then add it to the first, then no, 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 no. This is
Yeah, yeah,
exactly
yeah. You're right. You're right. If it is suppose it is 2, it is 1, and sorry, it is 1, it is 2, it is 3. Okay, this we are representing. We add the second and third vector, and minus 3 times the first one, we'll get 0 0, right?
Sir, I need
Yeah.
to confirm one
So
thing that about the second option, can we directly say that zero vector is the element of span? Because if the set is empty, like the vector space is zero vector space, then the span contains it.
yeah, we can see.
So without even checking, we can say that zero vector is inside a span of
Yes.
uh, R2.
Okay, so but our goal is to find this set of coefficients. Okay, so these are the coefficients. So
Okay.
I mean, what coefficients? A times this vector 1 comma 2 plus b times second vector. I mean, we are taking a random linear combination. Okay, a random linear combination of these vectors of S. Okay, and then we want the resulting vector. And if we are able to find some combination of A, B, C, then we are done, right? That vector is actually lie in the linear span, right?
And if it is not this simple, then
Hmm.
we have to do the Gaussian elimination, right? Like the first component of all the vectors added together to zero, and the same equation will form, and then we take the matrix and then do
Yeah,
Gaussian elimination.
actually, this is the Gaussian analysis. See what is happening here. This is A, this is 2B. So A, okay, plus 2B and plus C. So this will equals to, okay, this will equals to what? The first coordinates. Suppose this is X and this is Y, but they are known. Okay, they are known. They are not variable. And so we this is equal to X, and the second coordinate 2A plus 3B, okay, plus, sorry, minus C, right?
Okay.
This is equals to Y. So see, we able to form the system Ax equals to,
Hmm.
okay. So our goal is now to find the solution. So goal is solution should exist. If yes, then then it is the linear combination.
Hmm.
And no, then not linear
As linear combination.
combination. Okay, so this is how we do this. Okay, so this is looks like a very lengthy process, right?
Yes.
Yeah, but this is the way. Okay, this is the way, correct way to solve this. I mean, you can do this calculation very fast. I mean, what is the goal? What is the goal is to find the solution for this system. So you can do this process very fast. You can find the solution. This is the solution set, minus 3 1. So you can directly see if you add these two and subtract the minus 3 times the first vector. See, minus 3 times the first vector plus 1 plus 1. Okay, you can see we will get 0. So you are finding this solution fast. Okay, this is a different thing, but this is the way to solve this. Okay, can you suggest me one another way which is also lengthy, but there is a different way? Can you suggest me anyone?
Sir, we can write, so the span of set will contain the yes, unique combination of the all the elements of the vector of S, right?
Yeah.
In the
So
very first option, this 2 comma 3 is missing.
uh, 2 comma 3 is missing where?
In the first option.
So that means the coordinate is 0.
Yeah, but how can we assume it is 0, sir? It is not mentioned over there.
mm, no, we can write this plus 0
Sir,
times 2 comma 3, 0
yeah.
times 2 comma 3. So now the solution is, for first option solution is 5 and 0 and 8. Okay, this is the solution ABC, the coefficients. Okay.
Yeah.
Okay, we are not assuming, actually we can write it. It is unnecessary, we are writing plus 0, right? Okay, so one more way I was talking about, one more way.
So one
Yeah,
more way that I can think of, that we first calculate the basis of this S and then try to find the a combination. If it is not same as basis, then we might reduce some steps if this span is
yeah,
greater than this.
yeah, very nice, very nice. Actually, this is a one more way other than my way. Okay, so what is the way? We can reduce it. Suppose this is a dependent set, and we can reduce it to some extent, and then we will have a simpler system to solve.
Yes.
Okay, simpler system to solve. So this is one way, and there one third way. So don't think about that we are taking too much time in one question. Okay, I'm not solving the question, because questions are for you to solve. I'm talking about the concepts through the questions. Okay, remember, my goal is not to solve this one question. Okay, I'm discussing
Yeah.
concepts here, so that's why. Yeah, so third option is third way of solving this is, we can find the vector space. Which vector space?
This this uh,
Span of.
for which this span is exists. I
Yeah,
don't know how to say.
yeah, we can see that. So so that's why I say this is not a basis. Okay, so it can be dependent set, but still the spanning set of this dependent set also be a vector space, right?
Yes.
Yeah. So we can take this vectors and find the vector space. How do we do that? So suppose we have a vector space. Okay, I'm not talking about this question. Suppose a vector space, any vector space, suppose x comma x, such that x is a real number. Is this a vector space?
X over X is a real number.
Yes, sir.
Oh
This
yeah,
is a
it is.
vector. This is a vector space, right? So this is any vector space. So if we found this, once we found this, we can directly check which vectors are lying this. Suppose, so it is saying both the coordinates should be same, so we can directly check the options. Okay, which are the options have the same coordinates. Okay.
Oh, okay, okay. Yes.
Okay, so once we have the vector space, we can directly mark all the options. Okay, which are true.
Mm, yeah.
Okay, so how do we find the vector space using this set? Someone.
Um, one, three. I don't know.
So
Yeah.
c times this xx, like any constant times this xx,
uh,
will give me the
Constant
span of this particular vector space.
c times, I mean any constant times this vector set.
This
What
particular
is it?
vector, yeah, which you have just given the example. Then we
Okay,
can get
so
that span. Yeah.
this is not one vector. This is a set of vectors. So c times what? C times the set.
So like you have taken this x comma x, no, which where x is real number.
Yeah, you are talking about this. But I said this I just taken for example. Okay, not for this
Okay.
question. I'm just saying
You asking for this.
vector space for this question will be something different, right?
Yeah.
Yeah. So
Yes, sir.
how to find the vector space for this? But I mean how to find the spanning space?
Yeah.
So we multiply each of the vector with a different constant.
Yeah, exactly.
And add
So
them. Yeah.
yeah, so we do a times this, b times this. So what we have done here also. Okay. So but now what we are doing here, we are solving it for particular option. Okay, for some particular option. But here we will just take the linear combination of these three. Okay, and then so this actually set would be, I mean, our goal is to find all the ABCs. Okay, basically the
Hmm.
solution for this. And
So,
so
So
in
can we please check the other two options in this approach, the one you just said?
this one, finding the vector space, or
Yes,
or
sir.
or, or the
Yes, sir.
simple
Yes, sir.
is.
No, the
I,
vector space one.
okay, so we will find the vector space for this. Okay.
this will be,
Oh, I think we have to equate it someone, right? Something. Suppose we have this. So this A times this vector one, two. Oh, no need. Okay. So I have already written this here. Okay. See. So this is the vector space. Okay. What is vector space? This is suppose 2A plus 3B minus C. This is a plane. Clearly, you can see because it is R2, so a plane would be a vector space. Okay, and such that A comma B comma C belongs to some real number, and so this will form this is form a set. Suppose S dash. Okay, this is vectors. This is the spanning set. Okay, so now if you give me any point, then I will just equate that point. I mean, I will put that point into this equation of a plane. Okay, and then see whether this point is lying in the linear combination of this or not. Okay.
I don't get it. Like, can you solve any of the options with that?
Okay. Uh, so there are no. This is just clearly saying 2 minus 3 5. So it is, there are
This
no
is
other option.
uh, the third one is S, and the fourth one is also true. Because the first option is
Oh, sorry. I'm really sorry. I just really messed up here. Okay. This is not the equation of a plane which is spanned by these three vectors. Okay. So see, uh, because it is R2, so only two of them are independent, right? So we'll take any two vector. Okay, and then because R2 means it is a line. Sorry, in R2,
uh,
yeah, it is a line, right?
So that would have been okay too. It will still be right.
Yeah, so it would be line and line. Then so we can take any 2 point independent, and then write the line equation for of a line, y minus y1 equals to m times x minus x1. Okay, so this way you will find. So suppose we take these two vector 1 2 and 2 3. They are independent, right? 1 2 and 2 3. So we have taken 2.1 2 and 2 3. These first two vectors. Okay, and then
Yes, sir, they are independent.
yeah, they're independent. Then what we do, we find the equation of a line. So y minus y1, suppose this is x1 x2. Okay, this is x1 y1. Okay, so we'll take y minus 2, and m would be, what is m? 1, right? 1 upon 1. Do you know how to find m?
y2 minus y1 upon x2 basically.
Yeah, yeah, upon y. So this is x minus x1. So equation of line is y minus 2 is equal to x minus 1. So forget about the previous thing that I told you, this equals to, or and abc are any real number. So forget about this at all. So what we do is, we just check it is R2, or I mean how many are the independent vector basically, and those one we take those one and find the equation here. Okay, and so this is equation y minus x equals to 1. Is that clear?
So this is like the span of that particular vectors.
Yes. So this line actually,
So can we like say that's we can like this line is fine, but
hmm,
we can say for a point also, like if we generalize it to A B or C terms only, like for
hmm,
this particular question,
hmm,
if you do the same thing like A into 1 comma 2 plus B into 2 comma 3 plus C into 1 comma minus 1,
hmm,
then we get something in X and Y that
hmm.
is there,
Yes.
and for that particular x and y, we can directly say that a b c belongs to real numbers, so it is in R2. So can we say
Uh,
also like
yeah,
that?
yeah. Actually, that's why I have written that. That's why I have written that. But then again, I was just confusing it with the plane equation of a plane, because they are looking three variables. But equation of plane is something like this.
Yeah, but sir,
Something.
this is variable. This belongs to real R only.
Yeah, yeah.
Yeah,
So that actually form a vector space. Clear. Sorry, not a vector space. A spanning set.
planning
Okay.
set. Yeah. Okay.
Yeah, it's a spanning space, but we did not get too much from there, because we have to equate it x and y. So I'm talking about the different approach to
Okay,
solve
sir.
this question.
Fine.
So it will be the same approach. I will take that and equate it to the x and y, and then make this
Yeah.
system and solve. So that will be the same.
Okay, fine, sir.
So I can write that, but I just removed it because that was not incorrect. Something not incorrect. That was just you may be confused with this plane. That I was confusing. Okay, like I was confusing. So okay, so here we find this equation of the line, and then all the points on this line are this are in the spanning space. Okay, this is not a vector space. Clearly, you can see it is not passing through origin. Okay.
Sir, I have a confusion.
Yeah.
So in this span, so this else, these three, one of these three should be a linear combination of other two because it is a span over R2.
Hmm.
But I am not able to identify which is the dependent one.
So for that, because 0 0 is always a point in the vector space, right? So
Mhm.
if we include in this line, if we include 0 0 as well, so I mean, so then we have to remove one vector. Suppose this, and we take instead 0 0. Then we make the equation, line of equation. Then we take 1 comma 2, this point and this point. Then it will be a, then it will be a line. Okay, but
So
not
what
R2.
will
This is
be
this
the
is R.
base?
Not
Yeah.
R2. This is not R2. This is in R. Okay, line is in R.
Mhm. What will
Okay.
be the basis of this span?
Basis of this is any of the two. This is the basics. Suppose 1 comma 2 and 2 comma 3. This is the basis.
1, comma 2 and 2, comma 3.
Okay.
Okay.
I got your point. What you are saying? You are saying that if this is the basis, then the vector space which is spanned by these two should be a vector space, not this finite space or the line, right? Not passing
No,
through
no,
it.
no. I wasn't talking about this. I was just saying that I am not able to identify the uh, dependent vector because it is is a subset of R2. So the number of independent vectors should be 2.
Yes.
I think this is 10. And I'm not able to identify the third that dependent vector in this
Okay. Okay.
span.
So this is
Like
your
if
important
I try
question.
to
Yeah.
calculate
So
basis,
yeah, first I will solve this question, but please remind me again. I'm just talking about I'm also actually want to see these two vectors. Okay, these 1 2 and 2 3. uh, the suppose this is a basis, then it should span a vector space, right?
which means then 1 minus 1 is a dependent vector. But I am not getting it on
Yeah,
these two.
your point is very simple, that it can be cleared very easily. Take the three vector, what are 1 2 2 3. Your point is just see 1 2 2 3, 1 minus 1, right?
Yes.
Yeah, then make this, and we will reduce this r r e f. Okay, then so suppose what we get, we'll subtract the row 1, sorry, row 3 minus row 1, and what we get 0, and row 3 minus row 1 minus 3. Here we get 2 3 1 2, and then again we will divide this by 1. Okay, the third row, row 3 by minus 3, then we get here 1. Okay, so I may changed this row as okay. Now we get this 1. Now what we do,
I
we'll
need to remove the 2 also there below 1.
yeah, so r2 minus 2
2
times
minus
r1.
2 times R1.
So here it will be 0, and it would be minus 1, right?
Yeah, minus 1 and
2
below that 0.
0 1, and
Mhm.
then we will take r2 divide by minus 1, or just multiply by minus. Okay, then these two row would be same, so we get 1 2 0 1 0 0. Okay, so here it is actually no need to reduce it, because we can already see there are only two variable and three equations, so one variable must be independent. Okay, sorry, there will be two dependent. Okay, two are the pivots, so two dependent variable. Okay, so see, so any of the two. So you don't say that which one is independent, because a singleton vector is always independent, so you can take out any of the one. Okay, are you getting my point, what I'm saying?
Yeah, that is true, but still I'm not able to find any linear combination that fits this uh, like
That,
uh, like two this first and second vector. If I take these, I am not able to find any linear combination that forms the third vector, or maybe I take any other combination. 1 and 3, I try to form the second vector.
oh, okay. So see, for that, which is very simple, you going back in the concept. So what you do, you find this combination for the 0, right? 0 0, which is this. So take this combination, minus 3 times 1 2, okay, plus 1 times 2 3, and so the third vector is minus 1 1. Take the minus sign here, so it is minus and it is plus. So just combination is 3 minus 1. If we take 3
Okay.
minus 1 from the 2, we'll get the third vector. Okay.
Okay. Yeah. Thank you, sir.
Okay. So I was talking about this thing because it is R2, is a subset of R2. Okay. So that means only two vectors are independent, and using those two vectors, we can span some space. Okay. So so okay. So what would be the span of R2? I mean, what would be the vector spaces in R2? Okay. What would the vector space? This is R2, right? So what could be the vector spaces in R2?
Line passing through origin.
Line. Okay. Only the line, right?
Yeah, yes, I think so. Only the lines.
Because plane, we cannot take plane because plane would be like
Yeah, then entire R2 will be covered.
yeah, entire R2. Yeah, but where we can take that plane, we can say that a plane, right? XY plane. Okay, so these are two vector space. Okay, so in R2 we should able to span the whole R2. Okay, whole R2. So using these two vectors, yeah, now it is clear. Actually, I was confused. One, two, two, three. These using these two vectors, you can span the whole R2. Okay, I'm just taking only this line, but if you take another line, okay, using these two vector, I took this line, okay, but zero vector is always there in order to become a vector space. Then we can take these two and these two, then we get another line, and take the combination of these two lines, we get another line, and this is how we'll span. We get different lines which are passing through origin, and we'll span the whole
Uh,
R2. Okay.
I have a doubt in this thing. That
Yes.
what if the lines don't pass through origin? It cuts.
Then it is not a vector space. Clearly it is not a vector space. That means it will not follow the properties of a vector space, that a vector space will be closed under addition. It will not be closed. I mean, you will take any 2 point on those line, you add them, you may get a point outside the line.
So
Okay.
we can generalize this that a
Hmm.
vector space in Rn always pass through origin. Like the vector spaces in Rn always
Vector space in
Rn, like in R2, a line pass through origin. In R3, a plane pass through origin, and further, a vector space in Rn always pass through origin. Can we say that?
yeah, any vector space must pass through origin. Okay. So in
So it
R2,
must have a zero element.
yeah,
Yeah, yeah,
it
zero
must have.
element.
Yeah, so so it pass through origin when the addition is defined such a way. I mean, usual addition, we call that usual addition. If we have defined the addition, the definition of addition
Yes, yes.
different way, then the
Hmm.
origin will be shifted, but it
Hmm.
will it will be similar. It will be
Yeah.
isomorphic. Isomorphic. Okay,
Hmm. Hmm.
just
Hmm.
remember this word isomorphic. It is
Okay.
not important for this course, but it is more general term. Isomorphic, I mean, isomorphic to R2. I mean, in R2 we call it 0 0 as the zero vector, but if we can rotate this or maybe shift this, and we can do something, okay, then we get a different space which is also equivalent to R2. Okay, so in this question you have understood certain things. uh, this is spanning set. Okay, it can span the whole R2, and because there are three vectors, so we also know only two are independent and one is dependent. Solve the second question. Now we will solve quickly. Okay, what is the second? Take your time and just solve this. The S is given, and asked for the elements of the span of S. And the previous question, actually, I gone too far. I have added the 0 0, but 0 0 is not in S, right? That's why it was not a vector space. See, I mean in S, but span of S contains 0 0. Okay, so that's
All
why
four are correct.
here in the
Here,
second option.
first two three are like are you solved it. So the last option is incorrect. And else, so this first is a very clear thing. Two times the first vector and one times the second vector.
Actually, these two questions are very similar, so you can solve it. If anyone has doubt, I can solve this third question.
Okay.
So who have solved the question, raise your hand. Okay, I think I should discuss it. I should give you like some certain fixed amount of time. Let's say four. Yeah, you can lower your hand. Himanshu. I'll give you 2 minutes, 2 more minutes. Okay, all of you.
Sir, can you please share the screen so that we can see the question?
Okay. Okay, so let's discuss now. So, anyone who did not able to get this question correct? Okay, so I just say it is clearly written here. You can take out the determinant and check whether which set is independent and dependent. Okay, or one more thing you can do. You just form the matrix and apply some row reduction operation and check whether any of the row is becoming zero or not. There also you can consider this set.
Excuse me, sir.
Yeah,
So it is also written like S is a basis of the vector space R3. Like it is the correct answer. These two linearly independent set that I understood.
linearly
That is,
independent. Independent is true.
yeah, it is true, sir.
Okay, then it is a basis for R3. I
So
mean,
like basis.
if this is true, then the basis is also true.
Okay. So like I'm just a little bit want to understand the basis part. Basis is something like where we uh, where the set of the vectors
These two,
will be unique
these two,
or something
these
like,
these two condition.
yeah, minimal. Okay, okay, fine.
Maximal independent vectors. Maximal independent is so what are the maximal independent vectors in R3? Three, right?
Yeah, yeah.
So if we get three independent vectors in R3, we get a basis, right?
Independent vectors we are basic. Okay, okay, sir.
And this the second statement is equivalent to the first.
Yeah,
Minimal spanning.
yes,
This
sir.
is a minimal. I mean, minimal means if you take a smaller set, okay, we will not be able to, a smaller set of the bases, then we will not able to span the whole vector space. Okay,
Okay, sir.
for that it is basis for. Okay.
Sir, so in this question number three, just to scroll it a little bit. What I have done is differently. Like what I did, I see that this second vector contains zero in the first element, or zero as the first coordinate or element of this vector, and the third element. And
Is zero.
the
Yeah.
third vector has zero as the first element, and first vector do not have any zeros. So
Yes.
what I tried, that if I can get the zero in the first vector also, like I was trying this, and I couldn't find the possible way,
Yeah,
so
yeah.
I just said that
Yeah, if you're able to find, that means the first column is zero, right?
hmm,
Yeah, entire column would be zero. That means determinant would be zero. So
yeah.
in that case, it will be a dependent set. Okay.
So is this method okay? Like it's just
Uh,
fast, like I can see and
no, it is
instantly
not
get.
okay. It is not okay because suppose you are able to find the zero at the first, okay, and you are
Hmm,
not getting somehow, okay, you are not
hmm,
getting, but there is a combination, so through that you can get a zero. Suppose, so in that
hmm,
case you will just declare them it as independent, right? So that's why I go through the proper process of Gaussian elimination
hmm.
or Gaussian reduction, root
Okay,
reduction.
okay. Thank you.
Okay. Fourth option is saying these are the choose a set of correct option. Yeah. Tell me which option is true. What about the first one? And first one, do we need to solve this
No, sir.
for mark? No, no, right? Because this is not a minimal
Spellings.
minimal spanning set or
Independence.
maximal independent set. It is not
Yes.
maximal. Maximal
Yes.
means uh, if we maximal means if we had one more vector, then it would be dependent. But it is already dependent. Okay. So yeah, so basically it is not minimal spanning set. And if we remove one vector, still we are able to span R2. Okay. So that's why it is, because it is not minimal spanning set, it is not true. Second option,
Second option is true.
yeah, it is true because the first vector is not the multiple of other. Because if there are only two vectors in a set, we just check if c times or alpha times the first vector is the second vector. Okay, if it is true, then they are dependent. Okay, basically the multiple of each other. So clearly, this is not true for this. Second option is true. What about the third option?
If sir,
Hmm.
for the second option, if
The
we
second
have
option is also correct.
Second option is
in
true. Yeah, I'm saying second option is true.
Hmm, okay.
if
Third
we
option,
if
yeah.
so in the second option, if we had another set which is linearly dependent,
Hmm.
so then it still be true or false,
If in the second option, if we had one more vector, then it
which
will
is
definitely be dependent. Definitely, not cannot be independent. Okay.
if we have dependent, then is it true? because in the lecture, ma'am asked that there should be at least like for R2 there should be at least two independent vectors.
Mm, for two independent vector for spanning R2. Yeah, at least two independent vector for spanning R2. But in order to be a basis, it should be a minimal spanning set. Not only the spanning set, it should be minimal spanning set. Okay, because only these two vectors are enough to span R2. So this is minimal. And if we add one more vector, then it will not be minimal. Okay, it will be extra. Okay. What is the third option? It is true. Third option is a multiple of other?
Uh, it's not a multiple.
Clearly not a multiple because
Yeah.
both should be negative. -3, -1. Then it would be a multiple.
So,
This is also
sir, in a basis, can we consider that there is always zero vector is always there, but we don't count it in cardinality?
yeah, very important point. Zero vector is always there included in the no. Sorry. Basis we don't write the zero vector, but zero is the linear combination of these
Hmm.
the basis vectors. Okay, I mean spanning set of the basis will definitely contain zero.
Oh,
Spanning set. Okay, so what will be the coordinates? I mean, what will be the one coordinate? 0, 0, right? 0 times the vectors. If we add them, we'll get a zero vector.
okay.
Yeah. Yeah. So now, previously what I was discussing, just now it is now here, here, here. Yeah, I'm talking about this line. Okay, I will find this line, so whatever it is. So instead, this you can do like take the basis vectors. Suppose in R2 we find in that question we find two vectors. Okay, suppose this is one, this is two, and you can see the linear combination of these two is 0, 0, right? 0, 0. I mean 0, 0 is also the linear combination. Okay, so in the spanning set of these two, zero vectors also lie. So we will take these three vectors, and so using 3 points we will get a equation of a plane. Okay, this triangle suppose,
Hmm. Okay.
and we can expand this, okay, in every direction. Okay, we can make it large, so that it will span a whole arc.
Okay.
Okay, so and this is solved. Key points to maximal or minimal spanning set. Yeah, solve this fifth question. Should take a screenshot. Yeah, all of you solve this question. So it is asking for maximally linearly independent set in R2. So what will be the number?
Two,
Okay, there will be
Two
two
vectors.
vectors. One will be
two
two
vectors.
vectors.
Yes.
So this is not right,
Yes.
but because it is asking for maximal, it is linearly independent, but not maximal, and it is a vector in R2. Everything is true, linearly independent set in R2, but not maximal. Okay, I mean we can add one more vector. Okay. What about this second option?
It's
This is
not.
linear independent. It's dependent.
Yeah, 1 2 times 2
There is
is
only two points.
second vector, not
Hmm.
What about this?
Correct.
Yes, sir.
This
It
is
is
correct.
linearly independent and also
Okay.
Maximum.
What about this?
no,
This is
sir.
not right.
It is maximal but not independent. So
Yes, sir.
I mean maximal but not independent. So both are maximally linearly independent, not independent. It's not true. What about this?
This is true.
Standard
Yes, sir.
basis.
Yes, sir.
Always true. Solve this question. Sixth one. So it is saying which of the following sets are minimal spanning set in R3. So minimal spanning set means three vectors. Okay, you already know now by now. So is it three? Okay,
No, sir.
these are three vectors. Should be true. Is it true?
Yes.
Yeah. So we can check it. Just another determinant or put it in a row. So it is easy to see because here is zero, but here it is non-zero. So using two non-zero, we cannot get the using two zeros, we cannot get non-zero. Okay, and if we take any linear combination of these two, we cannot get this. Is it clear?
No, sir.
Yes.
Please, can you repeat?
Yeah, I'm saying here it is zero, and here it is zero. So we if we multiply any by any number this vector and so add this and this, uh, we cannot get a non-zero using two
Yes.
zeros.
So it's linearly independent. Yes.
Yeah. So this thing I used it for a third question. That's why I was telling that I just compared the two rows and said that it is linearly independent.
Using two zeros, we can for second option.
So
So
second and third.
yeah, now you can check actually. Okay, this is clearly not true. Uh, this is key point three. It is about basis of a vector space linearly independent subset V that
And what
spans.
about the third option in that question? The question that we're doing.
Yeah, what so third option is it is independent or dependent?
Linearly dependent.
Linearly
Dep-
independent.
Dependent,
In
I think.
No, so linearly dependent because the third vector is just the linear.
Combination of first and second. If we add first and second, we can get third easily.
yeah, or if we take these two vectors and add, what we get one.
Not for third. I'm saying for
Third is
fourth.
independent.
Third
The
is
third
independent.
option. Fourth is
Dependent.
dependent. First and second combines to form third vector.
Yes, yes. That's what
First
I
and
think.
second are combined to form third vector.
Yes. For
In
the
the
fourth option.
fourth option is independent.
That's the fourth option, sir.
Yeah,
Third
fourth
option is
option
correct answer.
isn't correct, right? That's what I'm saying.
Yes.
Yes, sir.
Okay, so this is saying by solving fi is what are this a base vector v linearly independent subset of v that spans v basis of a vector space. I think it is same. I don't know what they have written here. Just solve this question. You can read that okay that hint whatever given above. Solve this. Is it visible to everyone?
I think
This
it's similar as the third question.
Yes, sir.
okay.
It sounds similar to the third.
solve this.
This
I
is
think this is
also similar. It
why
is
they are repeating questions. I don't know. Actually, concept is the same. That's why they are repeating questions. Okay, so do one thing. Um, solve. Okay, okay. Let me go through. Otherwise, there will be a silence. Take the different question. And this looks little different. I mean, you have to read something. Solve this ninth question. Solve this question. Okay, so let's discuss. Anyone want more time?
I am not getting the question. I'm not getting the concept.
Okay. I'm explaining the question. Question saying, uh, so these are the two conditions should be satisfied by the point x, y, z, and collection of such points is forming this vector space. So, and what are these points? So suppose this is a z axis, and this is y, and this is x. So we have one line in yz plane. Okay, y and z plane. Okay, you just try to imagine. Okay, yz plane. So let's pause. So what is the first line? What is the first line?
2x plus 3y equals 0.
X plus 3y
2x plus 3y
2x plus 3y
equals
equals
0.
0. And what is the, the second one?
Y plus
Y
5z
plus 5z equals
equals
0.
to 0.
5x plus
Y plus 5z, y plus
5z
5z equals 0.
equals 0. So, so see, these are the two lines. One is this red one, okay, and another is, so this is y and z, yz. This is the line, okay. I mean, just they make it plain, but this is a line, okay. Yeah, so that's why it is actually expanded in 3D, okay, but it is considered it is a line, okay, the blue one, not a plane. So this is
Uh,
one line, yeah, this is second line, and together they will form a plane, okay. So
my doubt is, do we need to check both the conditions for each of the vector in these options? Like the first option I selected, not selected because it is not following 2x plus 3y equals 0, the first vector.
hmm,
And second option is following that for
hmm,
the first vector, and so should I check for the second condition for the first vector also? So both the conditions for both the vectors, or
yeah,
how it is checked? I am not sure about it.
both the conditions should be checked, okay.
Both the conditions will be checked.
Yeah, so see, suppose the first point 230, and check in the second condition. The second is y is 3 and z is 0. uh, so it is not there, okay. Understood? Because it
Hmm.
is saying and. So first is
Yeah.
not true. First is not true. And which option is true? Can someone tell
Uh,
me which?
Third
fourth,
and fourth.
third and fourth.
Third and fourth.
Fourth, third, and fourth to C. So suppose take this point, and it is satisfying in the first equation
Yes, sir. The second
and
equation.
the second equation as well, because minus 10 plus 2 times 5. Okay. So second equation is satisfying. It is 0, and first equation it is satisfying. 2 times 15 plus 3 times minus 10. Okay. Minus 30. 30. Okay.
Excuse me, sir.
Yes.
Also, I have doubt regarding. I mean, the why the first and second one options are not satisfying.
See, why it is not satisfying, because it is not in the span, okay. I mean, if we take two lines, okay, two lines will span a plane, right?
Correct. Yeah.
Some plane in r3, okay.
Hmm.
So that plane actually, so these points are not lying in that plane, okay, which are spanned by these two lines.
But if you see, like let us say that the first one, 230 and 015, they are nothing but express in terms of the vector of the equations that they have given. Like let us say, yeah, 230 and the second is 015.
3 2, so 3 times 2 plus 3 times 3 times 2 and 3 times minus 2. So they are 6 minus 6 0. So it is satisfying the first equation. Let's talk
Correct.
about the second equation. Minus 2 plus 5 times 0. Okay, which is minus 2 not equal to 0. So it is not like, because it is saying that the definition of the vector space is and, not or. And it cannot be or, but yeah, it is not or.
Okay. 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 Got it.
Now let's take a different question. Some nth question is also is a lot. Okay, this is hint actually. Question is easy, so let's leave it. Uh, yeah, solve this question. 11. I don't know. This is also could be easy, but just solve it. Yes, so this is interesting question because it is asking about the dimension, and dimension is number of independent variables, number of independent vectors. Okay, vectors in spanning set. Okay, so or another sense, uh, number of dependent variable. Okay, this is also equal to the dimension. So our goal is to find the number of dependent variables. So here it is saying x plus y is equal to z plus w. This is the first. So how many are independent here? Any one could be independent, right? I mean, any of the one vector can be written in terms of other. Okay. So one variable from the x y z w would be independent, and from this equation we can write suppose w in terms of minus x plus y plus z. So one vector from here. So basically two dependent variables. Okay, two dependent. Two dependent, that means dimension is two. Is that clear?
Okay. But if we are taking this vector has four elements. I mean, each vector in this vector space has four elements. So,
Oh, I
uh,
think. So sorry. Take a moment. Please, give me a minute. Dependent or independent variable? I'm just checking if we have any. Okay, just you guys also think. I'm also thinking. Let's take one more minute. Okay.
okay.
So what are we thinking about?
I'm just saying. Uh, the dimension of a vector space is equal to the number of dependent variable or number of independent variable. In this case, there are two. I mean, they are same. So, so anyway,
The
it is. Yeah.
dimension is about independence, sir.
Yes, independence, not.
So,
That's what
what
I
is
was
the
just.
terminology used for
Yeah.
all the number of the variables in vector, total number of variables in a vector? Is there any terminology for that also? Like, if a vector is expressed in 3 points, then it is in R3, maybe?
A vector is represented in 3 points. So this is the vector in R4. Okay, okay. So
Yeah,
R4
R4.
means that there could be four independent variable. Oh,
Hmm.
sorry, there would be four variable.
Yeah, four
So
variables. So,
yeah,
what is the terminology related to that? The four with the four. What should I say? What four is?
four is the yeah, I understood. 4 is the dimension of this vector only, not the vector space. Okay, 4 is the dimension of this vector.
Okay, this factor.
Only a vector.
Mhm.
I mean, any vector in V is a 4 dimension, but in 4 dimension, suppose R4. Okay, but in R4, this vector space is a subspace. Okay, clearly lying in R2 only. R2 is a subspace, right? You already
Oh,
know this. Okay.
got it.
Okay, so this is important. Number of independent variable actually. Okay, if we are talking about variable, number of independent variable from the dimension of the vector space. Yeah, it is true also. Basically, independent variables we will some suppose these are two D and suppose C. Okay, so these two will be changing. So clearly, it is two dimensional. Okay. Yes, so number of independent variable are corresponding to the dimension of the vector space. Okay. Got this. Okay, so we have I think solved our one question is one or two questions are remaining. Yeah, solve this also, all of you. Okay, this is simple question, so we won't take too much time. So we will solve the next question 13. Okay, but just quickly, so see what is the diagonal matrix?
The matrix that contain non-zero element on diagonal, a principal diagonal, and zero element on other position.
Yeah, all rest of the entries are zero, only except this. Okay, so we can say diagonal matrix will always be a square matrix.
Yes.
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 Okay. So clearly, in order to span all the diagonal matrices in the world, we need only three real numbers A, B, C, right?
Yes.
Okay, so it is three dimensional. Any doubt?
Sir, the third option, right?
I mean, three dimensional, three independent matrices. Okay, so third option is clearly true, and the fourth option, it is 111, 111, 111. Okay,
Excellent.
so we can take like A, B, C and add them. What we'll get? A, 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 B, 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 C, C, C. Right? So this we get. Okay, and then we. So what is this? I mean, could be
Identity.
no
Oh,
identity
sir, you got
matrix.
that.
Identity matrix is
Sorry, sorry.
also diagonal matrix, But see, suppose if we take A as 1, B as 1, C as 1. Okay. Here, in this case, we are getting A, B, C, 0, 0, right? Everything. In the third case. But in the fourth case, we are getting this. So here, suppose we can get 1, 1, 1, 1, 1, 1, 1, 1. Clearly, it is not a diagonal matrix because it is a non-zero. Okay. Is it clear or no? This is not true.
Yes, it is.
Sir,
Okay. Solve.
the first option, sir,
Yeah.
sir, the first option is failed just because it was not a diagonal matrix, right?
It is a diagonal matrix, but it is not all the diagonal matrix. It is just this A, A, A. We take A times this. It is not all the diagonal matrix. Okay. In M3. Okay. That's why it is not true. Otherwise, it is a diagonal matrix. It is spanning a scalar matrix. Okay.
Okay, sir.
Scalar matrix. It is true. Okay. Solve this question. Third. So this question 12 we are solving, and 13 is a diagonal matrix. Sum of the diagonal entry. What will be the dimension of P? Some of the diagonal entries are 0. Okay. Then A plus B plus C is 0. That means we need only 2, right? If we know
Yes.
the 2, third one we will know. So we know so dimension would be 2, reduced to 2 for this case. Just solve this question, okay? 14th. Okay. So let's, yeah. Let's discuss this.
Sir, can you show the question?
So let's take the first. So for that, can you tell me what
Rank
could
is
be the
3 for both matrices.
maximum rank for Q? Maximum rank.
3.
Maximum. Okay. Maximum possible rank. Maximum possible rank is 3 only. Okay. That means if the is the first option true?
No,
Yeah. So take this
Yes.
matrix 1 0 3 2 minus 2 0 0 1 minus 1 0 2 1. Try to reduce it. Reducing it, we take R2 minus 2 times R1 and we get 0. Okay. And minus 2 and minus 6, right?
yes.
And 0 1 0 2 1. The first row is 1 0 3. Then what we do? We'll multiply by minus 1 the second row. Then and sorry, divide by 2. Okay, then we get this 1 and here we get 3. 1 3, right? Then what you can do?
Make this 2 in the last row.
This is one. We should make this 0. So R3 minus R2, we get 1 0 3, and we have 0 1 3 0 0 minus 1 minus 4 minus 4 will just become 1. Okay, by dividing minus 4 0 to 1. Okay, so you can switch these two rows and subtract R4 minus R2 two times 0 3 0 1 3. So this row we will switching. So we'll get 0 0 1, and then so this row will become 0 0 and 1 two times, so minus, so it is minus 5, which is 1. Okay, so and then we subtract this, then last row will become 0. Is it clear?
Yes, sir.
Okay, so it has rank 3. Rank is 3. Rank of P is 3. Okay, not 4. And what is the rank of Q? If similarly, if you reduce,
3.
so
3 only.
it will be 3. Okay, so this option is true. Okay, what about the last option or this option? It is 4 cross 3. It is 3 cross 4. We'll get a matrix 4 cross
4
4,
4.
which is equals to PQ. Okay, 4 for 4 matrix. So there could be the maximum rank 4. Okay, 4 4 matrix. Similar way, you reduce and find the look for the pivots. Okay, and number of pivots will be rank. Okay, so that's it. We have solved this all with us uh, and revised the concepts in this session. Any doubt in this entire exercise? Solve with us.
Excuse me, sir.
Yes.
Sir, I have a general question from this week only. Like the span, like in the lectures, not very concrete about the which lecture it is, but like it is mentioned by the professor that the span of two distinct vector, like which are not dependent, that will always give a plane in R3. So
Uh, See, a span of two vectors, you are saying.
which are independent, obviously, that will always give a plane in R3 and is passing through origin. Passing through origin, I can understand, sir. But like if it is
Yeah,
a
yeah, yeah, yeah.
S comma
Understood
y,
your question. Yeah, understood
okay,
your question. But 2 points cannot give you a plane. For plane, you need 3 points. But the third point in case of vector space is reserved, which is zero,
that is
zero,
zero.
zero.
Okay, okay. So we have to like
Take two non-zero points, then it will always give you plane.
okay, sir.
Yes. Okay. That's it. Good night, all of you.
Thank you, sir.
Okay, very.